with respect to database replication and partitioning, if you have a simple schema, it makes it a whole lot easier to break your database up into multiple parts. So I guess the best way to describe this is if you have a numerical key or something like that, which you can, each object in your system has a number an ID associated with it. Being able to partition your database along a numerical key can be a really valuable thing. And so, as an example, for one database that I built, all of the objects in the system had a sort of a home location associated with them, and so that home location ended up being also a database location. So there was a map that you could keep in memory of for which range of keys you had to go to which database. So it was a very easy process to determine where you needed to query in order to get your data, because you just look at that home location and in turn figure out which range it belonged to, and then figure out which database it belonged to. And another nice thing about that kind of design is that it becomes possible to further split your databases when they become too full. Say you have an empirical limit of 1 million items per database, and when you go beyond 1 million items, the database query time starts slowing down. Well, when you start getting close to 1 million, you just choose a partition point in your key space, and then take the data from that one database, map it into 2 databases, and then update your table of database instances. So simple schemas really allow your kind of data flexibility that you don't have if you build very complex schemas. And by and large, your databases really are for persistence. You don't need to end up doing very complex queries to put up web pages. And if you are doing complex queries to put up web pages, you could be running into much bigger scalability problems than just partitioning the data.
So that's only for like key searching, right? What if you searched based on like another column? Then you would have to actually search both.
Oh yeah, you might have to search in a lot of databases to get answers, but in a location-centric database, if you organize your keys by location, you can answer all sorts of location-based queries and likely hit only one database. And by splitting things up somewhat geographically, you end up with a situation where very popular home areas, say like downtown Manhattan or something like that, would be actually more partitioned, whereas into lots of separate databases. And so a quick query actually would bring things back that are more local, and then maybe Alaska would be in one single database. On the other hand, so basically, it's good to find the interplay between what types of queries you want to answer and how the schema itself is going to map into that.
How can is there any general strategy for database sharding? Especially with respect to social networks. Like for example, I guess Facebook also has its data shard. So here, so for example, if you're a friend, if there's a person and he has some friends, so there will be like foreign keys to those friends, maybe connections. So how do you actually shard that sort of data?
Well, so that's it's an interesting question, because you find that no matter how you organize things, the network of connections are in a social network is such that you'll never shard things perfectly. You'll never be able to query just one database to get an answer. Obviously, there will be specific queries where that will work, but as the connections develop over time, you find that you basically have to deal with the fact that certain types of queries are going to run across multiple databases. And that's, again, actually where caches become very valuable, because you take that hit once, and if that's a very popular profile, for instance, it'll be cached. If it's not very popular, it could fall out of the cache. And that's really why caching is so important in these social network style communities, because there's just no clean way to split database up that works for all the types of queries you might want to do.
So like when you're talking about partitioning, so if you say like your database can hold 10 elements, so once you're hitting like 8, you say create another one and then start storing.
And I put 4 in each. Yeah.
Put 4 in each.
Yeah.
So like change the keys.
Yeah, or not change the keys, but just sort of change the for each database you say this one will have all of the keys smaller than this number, than the boundary number, and then this other database will.
Choose your boundary number?
Well, I mean, one of the easiest ways is just to sort of split it down the median, so you get half and half, so that the data is sort of half split between one and the other.
So in this example, like your boundary would be 10, and then you just like.
So yeah, say database 1 contained elements 1 through 9, and database 2 contained elements 20 through 40, or 20 through 30. Sorry. If I was going to split one of them, then I'd have a third database, and that contains, say, 20 through 25, and 26 through 30. Or something.
And when you add, which ones do you add it to? Just like evenly add?
Oh, so what you're asking is like, well, so maybe my example wasn't a very perfect one, because like what numbers could I add in between there? So if you're generating keys randomly, there ends up being space that you can like find for new entries. What ends up happening is that if you're allocating keys sequentially, you're going to be splitting things up kind of behind you, but never in the sort of like the new area of the database, right? So if every new object that's created, a new key, a sequential key number is created, what's going to be happening is that you're splitting databases like behind you in the as like you're sort of leaving you're always splitting the frontmost database, and so and actually that's not necessarily like the most effective way to do things, because you're trying to split a database that's a hotspot, because there's all this new stuff that's getting added. So actually nobody generates keys sequentially for that very reason.